Hello and welcome back to another Duncan Codes. My name is Duncan, and today we are continuing with the University of Helsinki's massive open online course. So our objectives today are to become familiar with the term overloading, how to create multiple constructors for a class, and creating multiple methods with the same name in a class as well. So we're looking at the code that we've been working with up until now using NetBeans, where we've been coding along creating a person. So let's have a quick look. So we've got our person class here, our instance variables, which are private, so they're encapsulated within the class. We have our constructor here, so we're setting some of the details. We're passing a name, so when we call this constructor, we need to give it a name, and that will be set to the instance variables. Age, weight, and height are all set to 0. We've got a printout, so that will print all of the details about the person, a method to increase the age, return whether the person is an adult or not, to work out body mass index, and then a few other methods as well. All person objects are 0 years old when created. This is because the constructor sets the value of the instance variable age to 0. So we saw that just up there in the constructor. The only thing really being set by a user is the name here. Everything else is default set to 0. So let's have a look at constructor overloading. We would also like to be able to create persons so that the constructor is provided both the age as well as the name parameters. This is possible since a class may have multiple constructors. Let's make an alternative constructor. The old constructor can remain in place. So here we've got our old constructor, and then here we've got another constructor. We've got a new constructor. This constructor is allowed or legal in Java because it doesn't receive the same parameters. It doesn't have the same path parameters. So here, we've got one that's just receiving string name, and this one is receiving name and age. So now we've got two alternative ways to create our objects. So we've got this top one here, which is creating a person called Paul. We're passing the string name and then the int value here. So that specific line is using this constructor here. And then the next line down for Ada is using this constructor here. So we've got Paul is 24 years old because we're using these details. And then Ada, look here, there's no age being set, so her default value is 0. The technique of having two or more constructors in a class is known as constructor overloading. A class can have multiple constructors that differ in the number and or type of their parameters. It is not possible to have two constructors with the exact same parameters. So if we created this again, we would get an error unless, for example, we added in a weight to be stored in our instance variable, sorry. We cannot, for example, add public person string name int weight constructor, since it would be impossible for Java to differentiate between this and the one that has two parameters where the int parameter is used for age. So here, what they're saying is that we couldn't change this to int age and have one constructor with string name to age and one for int weight, because Java can't differentiate the int between age and weight, if that makes sense. So calling your constructor. We previously concluded that copy-paste code is not a good idea. When you look over the overloaded constructors above, however, they have a lot in common, and we're not specifically happy with this. The first constructor, the one that receives a name as a parameter, is in fact a special case of the second constructor, one that's given both name and age. What if the first constructor could call the second? That is possible. A constructor can be called from another constructor using the this keyword, which refers to this object in question. Let's modify the first constructor so that it does not do anything by itself, but instead calls the second constructor and asks it to set the age to 0. This is our original constructor, and here the code of the second constructor is ran and the age is set to 0. So we're still using the original one, but setting the age to 0, which is basically the same as this. The only difference is we're not having to write out loads of code for it. So here we've got this, so we're calling the person constructor again, we're passing the name, setting the age to 0, and we've saved sort of 3 lines of code that we don't need to write. The constructor call this name, 0 might seem a bit weird. The way to think about it is to imagine that the call is automatically replaced with the copy paste of the second constructor in such a way that the age parameter is set to 0. If a constructor calls another constructor, the constructor must be the first command in the constructor. Okay, so I've actually recorded this session already, but the video didn't record. So this is already completed, but I will tell you why and how we came across the answer that we've got. Below is a Java class that represents a pet. So we've got class pet with encapsulated instance variables. Remember, they're privates, they're encapsulated. We've got string name and int age. So exactly the same as we were looking at before, but a pet rather than a person. We've got two constructors. We've got one which takes the name and the age, and one that just does the takes the name. We've got public pet int age, and this Bella, age. So this one will print out the age and the name. And then we've got public string, which will print out the details. So what will the program below print? We've got an array list, and we're adding some details to our array list, and then we need to figure out what it's going to do. So what we've got here is the answer as Nagini 7 years, Crookshank 0 years, and Bella 6 years. So let's have a look at the code and see if we can actually work backwards from the answer to figure out what's going on. So here we can see that we're using the constructor that takes the name and the age. So that one, when we do the printout, is going to give us the pet name and age as well. This one, we've only got Crookshanks, so the default here would be to set the age to 0. Set the name to 0 if we're just passing a name. And then if we're just passing a age, what will happen is that we will print out the word Bella and then the age here. So we can see Agony is using string name and int age. Crookshanks is just using the name constructor, and then I think it was Bella just using the integer constructor. And if you have a look through these, you can sort of work backwards and figure out which one is the correct answer. Okay, so here we go. We have got our first challenge here, constructor overload. Hopefully you would have heard that I've just had a bit of a mess around with the microphone settings, so hopefully things are sounding a bit better now. So, constructor overload. The exercise template has a class, product, which represents a product in a shop. Every product has a name, location, and weight. So add the following 3 constructors to the product class. So we've got the constructor signature here, and then we've got a little bit of information, further information. So it creates a product with the given name, its location is set to self, and its weight is set to 1. We've got this one, which takes string name and string location, creates a product with the given name and the given location, its weight is set to 1, and creates a product with the given name and the given weight, its location is set to shelf. So let's move that to the left. Let's get our project open. So I've got mine open here already. Oh, what's going on there? There we go, projects. Why is that so big? What is going on? Hang on, let's just reset my windows. There we go, that's better. Right, move that to the left. This open, go to projects. So we've got the project open here. We've got 2 classes. We've got this one, which is the main program, and then we've got the product class, which we heard about earlier in the description. So we need to create 3 constructors. Let's create the first one. So we're going to have public product. It's going to take string name and this name, and then the location needed to be set to shelf. So we can see that location here is the second parameter. So we're just going to add in that as a default. We're going to set it to shelf. Notice they put a lowercase s, so make sure you put your lowercase in too. And what else were we going to do? And its weight is set to 1. There we go, that looks good. So we're going to write out another one. So we've got public product, and then we're on the second one now. So it's string name and string location. And inside that one, what we're going to put is this, and then name, location, and set its weight to 1. There we go. Finally, we're going to do public product, and we've got string name and int weight. And we're going to create a product with the given name and given weight, and its location is set to shelf. Okay, so we are going to do this.name equals name, this.weight. Are we going to do that? No, I don't think so. This. So we've got this name, shelf again with a lowercase f, and weight. Okay, that looks okay. Remember, we've got the green on the left here because this is a GitHub tracked project, and it's highlighting the IDE is highlighting that we've got changes. So let's give that a run. Let's test it locally and see what we get back. So we should get this. We've got tape measure can be found from the shelf. Plaster 1 kg can be found from the home improvement section. That's what we've got. And tire 5 kg can be found from the shelf. That looks pretty good. Let's give that a run and see what we get back. We'll test passed. Excellent. That is fantastic. So let's open our Git bash as well. So for those of you that are following along with GitHub. So I'm just going to right click on my project again just to get the file location. Go to sources. Dear Lord, there we go. Copy that. And then we're going to use CD and then insert. Get rid of that. Hang on, what are we getting rid of? Am I getting rid of that? Get rid of that. Oh, so here what's happened is, if you look on the end of my line, I put the backslash, but I forgot to put the double quote. So to fix that, all we need to do is put a double quote in here, and then that completes it, and you can see that it's moved to where we need to. So let's do git add, git commit is our next one. Oh, what is going on there? Where were we? Git commit M, so M is for message, and we're going to say completed part 5. Oh, exercise or challenge 5. I can't remember if we've been calling them challenges or exercises, but let's do challenge 5. Challenge 5? Yeah. And then we can do git push u origin and master like that. There we are. And if we have a quick look at our GitHub now, we should see that our last update was today. So today's date is the 21st. So that will be the one. So let's, in fact, you can see it just here. So this is the last one, updated 13 minutes ago. There we go. Let's OK that. Give that a wee refresh. And there we are. Close this down as well. Okay. So now we're looking at method overloading. Methods can be overloaded in the same way as constructors, i.e. multiple versions of a given method can be created. Once again, the parameters of the different versions must be different. Let's make another version of the grow older method that ages the person by the amount of years given to it as a parameter. So actually, let's let us open our other NetBeans project, NetBeans, so Apache NetBeans, or NetBeans 8.2 if you're using that, either's fine. Let's see if we can find our people project, and we can follow along with the updates as well. And this is another good project that you'll be able to track on GitHub. Right, let's move that over here. Move it to the left. There we go. Okay, let's close this one. We've got person here, so we've got those bits and pieces. That's good. And then what we're looking for is the grow older method. Where is it? Oh, we've not got one. We open the navigator. It shows us all of the methods and variables that we've got. So do we have grow older? I'm sure we made a grow older one because I complained about having to grow older. Anyway, let us add these in. So we can do public void grow older. So I'm just copying the code from the right hand side of my screen And then we're going to do this.age equals this.age plus 1. And then we're going to create a second method with the exact same name. So public void grow older. This one is going to take a parameter, which is called years. And we're going to say this.age is equal to this.age plus years. So we can see that this one, each time it's called, will just update a person's age by 1. But this one, we can update it by whatever we wish. So in the example below, Paul is born 24 years old and ages by a year and then 10 years. That's very unfortunate. So you can see that he's created here. His object is created at 24. We call the grow older method once, increases his age by 1 year, and then we can pass the parameter with the 10 years, and he grows by 10 years, or he gets 10 years older, sorry. A person now has two methods, both called grow older. The one that gets executed depends on the number of parameters provided. We may also modify the program so that the parameterless method is implemented using the method grow older int years. So we could, like they're saying here, instead of having this.age equals this.age plus 1, call the method grow older and just pass 1. So this dot grow older, and we are going to pass it 1. Let's see what we've got here. Below is a Java class that represents a counter. What will the following program print? So we've got private int value, private counter int value, this.value equals value, increase value, and we've got increase value there as well. So here it will be set to 1. Here it will be set to 3. Then we're calling increase value 2 more times. So it should be plus 2 there. So I would guess at 4. Did I actually select anything? Oh, bizarre. Not bizarre at all. My maths is just ridiculous. It's 5, isn't it? Starts at 1, plus 2 is 3, plus another 1 is 5. I don't know why I thought it was 4. Silly me. Anyway, let's have a look. Ooh, a two-parter. Right, I will close down my Apache NetBeans. I've got my TMC open though, somewhere. Where is it? There it is. And we've got overloaded counter 2 parts. So let's get that open and ready. Right, so part 1, multiple constructors. Implement a class called counter. The class contains a number whose value can be incremented and decremented. The class must have the following constructors: public counter int start value, which sets the start value of the counter to start value, and public counter, which sets the start value of the counter to 0. Then add the following methods: int value, which returns the current value of the counter, void increase and decrease, which increase by 1 and decrease by 1 respectively. Excellent. Right, so let's get cracking with this one. So we can create a new class and call that counter. Remember, it's a capital C because it's a class. We're following the correct naming conventions here. So we've got public counter, and we've got int start value, like that. We've got a regular constructor, which is just public counter. So we've got public counter. There we go. We have got public int value. So we got public void increase and decrease. So this method on the left has got an error, but that's because I haven't put a return statement in. So if we'll just put that in just to keep it quiet, we will obviously go back and update this as we go. We've got a public void increase. Oops. And we're going to have public void decrease as well. There we are. Okay, cool. Right, so let's just have a read through again, and we can start to add in our instance variables that we need. So we need the class counter, which we've got. The class contains a number whose value can be incremented and decremented. The class must have the following constructors. So let's create a value, an integer called value. For now, we can make that private as well. And the first one sets the value of the counter to 0. So we can say this dot value equals 0. So that's that bit taken care of. And then the one that takes the integer sets the start value of the counter to start value. So we can say this dot value equals start value, like that. That's good. What have we got now? Returns. So we've got our public int value, which returns the current value of the counter. So actually, all we're going to need to return is value, like that. So we're just going to return this variable here. We've got public void increase and public void decrease as well. So we can say value plus plus, and we can say value minus minus. So that will increase and decrease by 1. So let us have a look at the main. See what we've got in the main. Why is that not open? There we go. Okay, so they haven't actually given us anything to test, but we can create our own tests. So we can say counter c equals new counter, and then we can do c dot increase decrease and get the value as well. So let's call, not hash code, increase, and let's do that twice. So I'm holding Control and Shift on my keyboard and pressing up, and you can see that it duplicates the line. I'm going to do a value, and then I'm going to do a decrease, and then a value again. So, oops, let's give that a run. See if we get any errors. Ah, that's because I haven't created the toString method. So let us quickly add that in now. So the toString method is already created for us in a sense. It's pre-populated code that we can just add in. All you need to do to get that is press Alt and Insert. Alt is the key to the left of your spacebar, and Insert on my keyboard is just to the right of the backspace. Oh, wrong one. God, what has robbed me today? There we go. There we go. Let's give that a run and see what we get now. So I suppose if we actually want the printouts, we should really put some system outs in there, shouldn't we, to test it? So let's head back to our main, and then we can start to add in some system outs. So we can do a system out here. I'm just going to copy and paste this line, actually. We can... Do we want to delete that? Let's put that there, and what we can do... So with a return value, what you can do is return the whole thing in a system.out. Print line, and then wrap that in brackets like that. And then we've got a decrease here, and I will get rid of that. So we can test our code now and see what prints out. Okay, so this one is the printout here, and then we've got the first one and the second one, which are the top two, and the bottom one, which is the value. And we know that those ones are specifically it, because that's how our toString method is formatted. Okay. So let's give that a send off and see if we can get the first point. Real. That's fine. So the counter test increase with parameters is this second part here. So if we refresh this, hopefully we should have 1 point. We don't have any. That's fine. We'll get this second bit finished, and then we'll tackle it all in a moment. So, there we go. So, oops, jumping ahead of myself there. Implement versions which are given one parameter of the methods increase and decrease. Public void increase by, and decrease by. So we've got increases the value of the counter by the value of increase by. If the value of increase by is negative, the value of the counter does not change. If the value of decrease by is negative, the value of the counter does not change. Okay, so it's going to be an overloaded method with an if statement in it, just to confirm that we've got the correct values. So let's add this in here. So it's going to be a void method, and we're going to call this one increase, just as we did before. And then we've got int increase by. And what we can say is if increase by is greater than or equal to 0. There we go. So what we can do now is do value, or this dot value, plus equals increase by. There we go. And just below this public void decrease, I'm going to add in the same method but for the decrease. The public void decrease, and that's going to be passed int decrease by. And we're going to say a similar thing, in fact exactly the same thing, more or less. Decrease by is equal to, or greater than or equal to, sorry, 0, this dot value plus equals decrease by. Let's give that a run and see. Whoops, haven't added in any tests yet, have I? So let's go back to our main program, comment these out, but let's just delete it and add some new stuff in. So we can do c dot increase. So let's do 10, and let's add -1. Then we can do decrease by 10 and decrease by -1. And then let's just see, we can do a few system outs, can't we, to see what's happening at different stages, so we can make sure that we're happy with our code. Let's give that a run. So our first value is 0. We've got 10, 10, so that's good. So it didn't take the -1 away. Then we've got 10 and -1. I printed that twice, which we don't need. So let's give that a run and see what errors, if any, we get back. And start tackling those. We've only got one fail. Counter test, test decrease with parameter. So we have got, they're testing it with the value of 900. Let's recreate this, and we can see what we're getting and hopefully get this all sorted. So we've got c.decrease, and we're decreasing by 7. And then we'll system out in c.value. And I'm just going to system out print it as well. Let's see what we get. Oh, I added it. So that's meant to be minus equals. That's meant to be minus equals. So let's give that another run. Perfect. There we go. Let's submit that off. And let's get our git bash up. So again, just as we've been doing before, it's git add full stop, git commit -m, and we have completed part 5 exercise or challenge. I'll do exercise 6. And then we can just give that a git push view origin and master. Whoops. There we go. You can head back here if you wanted to, refresh your page, and you'll see, I think when we hit 4, is it 4? That it will start to change to a darker shade of green. I think it's about 8, and it goes quite dark like that. Quite satisfying when you get lots of green, dark green on there. So let's give this a refresh. Excellent. Oh my gosh, we finished that section. Wow, that was a short one. You've reached the end of this section. Continue to the next session. Primitive and reference variables. Excellent. Okay, well, let's close this down. And this is only a short video, so I'll get this uploaded as soon as possible, and I will start working on the next video straight away as well. But as always, thank you very much, good luck, and happy coding.